Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve or answer questions related to meteorology or aviation weather. Random 8-9 questions that will test your knowledge regarding stability of atmosphere, topics such as thunderstorm, etc. So let's begin and see how many questions we are able to answer with proper explanation and elaboration. Question number 1. A temperature inversion would most likely result in which kind of weather condition? First things first, what is a temperature inversion? So, we all know that according to ISA conditions, your temperature falls, the atmospheric temperature falls as as altitude altitude or vertical distance increases, right? As altitude or vertical distance increases. Let's say this is your ground surface. Okay, this is your mean sea level. And ISA says at mean sea level the temperature must be 15 degrees Celsius. Must be 15 degrees Celsius. Now, and then as you rise higher and higher, this temperature will go on decreasing. Meaning, now 15 degrees Celsius at the mean sea level will become 13 degrees Celsius approximately at 1000 feet, 11 degrees Celsius at 2000 feet, 9 degrees Celsius at 3000 feet, 7 degrees Celsius at 4000 feet, so on and so forth. Up to 36,000 feet, the temperature will go on decreasing. At 36,000 feet, the temperature is, okay, at approximately 36,000 feet, the temperature reduces down to minus 56.5, minus 56.5 degrees Celsius. Beyond 36,000 feet, up to 65,000 feet, approximately 65,000 feet, temperature remains constant at minus 56.5 degrees Celsius. Above 65,000 feet, the temperature starts rising, increasing. Okay, so this is what ISA says. The temperature falls as altitude increases. Now, the rate at which this temperature falls is 1.98 degrees Celsius every 1000 feet. Every 1000 feet. Okay, the temperature falls at the rate of 1.98 degrees Celsius every 1000 feet. Remember this. Now comes the concept of inversion. This is your ground surface, same ground surface at mean sea level. The temperature at mean sea level as per ISA should be 15 degrees Celsius. Let's say as you go higher from mean sea level, that is you climb from mean sea level to 1000, 2000 feet, and temperature instead of being anything less than 15 degrees Celsius is more than 15 degrees Celsius, meaning 18 degrees Celsius, 20 degrees Celsius, so on and so forth. So this condition, this particular atmospheric layer will be called inversion layer. Inversion, inverse. What is the meaning of inverse? Inverse is nothing but the reverse of something or the opposite of something, right? Inversion is nothing but reverse or the opposite of something. Inversion is opposite, unconventional, or the opposite to something standard or expectations. Okay, so this layer will be called inversion layer or inversion conditions, because inverse or opposite of the standard expectation has occurred here. So this is called inversion, where the ground surface the temperature on the ground surface is 1, but as you go higher and higher, the temperature is actually more than the temperature at the ground surface. Okay, so this is called temperature inversion. So, so this condition would most likely result in what? Clouds with extensive vertical development above an inversion aloft, good visibility in the lower levels of the atmosphere and poor visibility above inversion, an increase in temperature as altitude is increased. So correct option is option C. An increase in temperature 15, 18, 20 as altitude is increased. So option C will be the right option. Now why does this inversion happens? So inversion happens on very cold, okay, on very cold nights, early mornings, when the sky is clear, surface winds are calm, light, okay, and terrestrial radiation is maximum. Terrestrial radiation is maximum. So remember this. So these conditions favor the development or favor the formation of an inversion layer. So because of this combined conditions, the ground surface will become very cold. The ground surface will become very cold. And due to the process of conduction, that is transfer of heat or transfer of heat from the ground surface to the medium in contact with it, that is air. So due to conduction process, the air layer which is in connection with this ground or which is very close to this ground layer will also get very cold along with the ground surface. But there is a drawback. This conduction, the process of transfer of heat via conduction is only limited to a few thousand feet. Okay, so that's why only a few thousand feet of atmospheric layer in touch with the ground will become as cold as the ground surface. When you go above it or away from it, the atmospheric layer, the temperature in this atmospheric layer which is above this layer, atmospheric layer, will have temperatures a little bit more than or much more than the ground surface temperature of 15 degrees Celsius. That's why we call this inversion. The surface is very cold, but the temperatures above that are hot or warmer than that. So this is inversion. Now, when this happens, when inversion happens, the pollutants in the atmosphere get trapped in this atmospheric layer. Okay, so inversion is a signal or is a sign of an inversion is a sign of stable atmospheric layer. Okay, without a stable atmospheric layer or without stability or without stable conditions, inversion will it is impossible for inversion to develop, okay, or inversion to form, because the main criterion for inversion is that you should have calm and light winds. Now if the atmosphere is unstable, you do not have calm light winds, you have fast winds, okay, strong winds, and this winds will mix, okay, will mix the atmospheric layer, okay, so it will result in mixing. So the air layer near the ground will mix with the air layer above, and the air layer above will mix with the air which is located on the lower levels. So this mixing happens, turbulent mixing happens, and as a result, distribution of heat takes place, and that happens very rapidly. As a result, not the air near the ground surface doesn't become very cold, okay, as, like in stable conditions. Okay, so unstable conditions prevent inversion from happening. Okay, so for inversion to happen, you need a stable atmospheric layer. Next point, whenever the atmosphere is stable, the winds will be slow, let's say slow, light, calm. There won't be, will not be turbulent mixing. Turbulent mixing. As a result, all the pollutants in the atmosphere or condensation nuclei will remain trapped or suspended in the inversion layer. In the inversion layer. Okay, and this pollutants condensation nuclei will decrease visibility. So that's why the correct option will be option Charlie. Good visibility, no. You get bad visibility. Good visibility is possible in unstable atmospheric conditions where there is mixing of atmospheric system. Okay, so option A will be wrong because temperature inversion is nothing but stable atmosphere. A stable atmosphere will not result in clouds, in developments of cloud with vertical development or extensive development. Okay, stable atmospheric layer will result in low level clouds like fog. Okay, so clouds with extensive vertical development, that is not a side effect of inversion. So that is wrong. Next, the most frequent type of ground inversion or surface-based temperature inversion is that which is produced by what? Terrestrial radiation on a clear, that means sky clear, no clouds, relatively still, that is stable, calm night, warm air being lifted rapidly in the vicinity of mountainous terrain, movement of cold air under warm air, or movement of warm air over cold air. So ground-based inversion is frequently happens because of terrestrial radiation or nocturnal radiation. And the explanation is the same as one I gave here. You need cold nights, early mornings when the temperatures are very cold, clear sky so that terrestrial radiation is not doesn't get blocked by clouds in the sky, calm, light, slow-moving winds, and and hence terrestrial radiation reaches its maximum value. So favorable conditions for the formation of ground inversion or surface-based inversion, where the ground surface becomes very cold, the air in contact with the ground surface becomes cold along with it by the process of conduction, and you have very cold temperatures near the ground surface, whereas warmer temperatures above that inversion layer. Question number 3. Which weather conditions should be expected? Weather conditions expected beneath a low level temperature inversion layer where the relative humidity is high. So like I said, again, let's go back to this question number 1. So there is an inversion layer. Okay, let's say this is your ground surface. There is an inversion layer in the first 1000 feet where the temperatures are very cold. Let's say the temperatures are 10 degrees Celsius, and above this inversion layer the temperature is 20 degrees Celsius. Now they have asked us what weather conditions are we to expect in this inversion layer. Now this inversion layer will be a stable layer, calm winds, pollutants trapped in this inversion layer, condensation nuclei. Now apart from this, if this inversion layer also consists of 100% relative humidity or very high relative humidity, what will happen? Condensation will happen. That is, condensation will happen on this condensation nuclei, or whatever pollutants are trapped in this atmosphere, in this inversion layer. Water will start collecting around them, and condensation will happen. Gas will change into liquid. So condensation will happen around the condensation nuclei. Condensation nuclei are nothing but your pollutants. So as a result of this, when condensation happens at such a low level near the ground, you will get a low level cloud, stratus cloud, a fog, something like that. So weather conditions, smooth air, Poor visibility, fog, haze, low clouds, yes. Light wind shear, poor visibility, haze and light rain. Now light wind shear will be encountered at the inversion layer, okay, at the boundary of this inversion layer threshold, not beneath it, not below it. So that's why we eliminate option Bravo. And light rain, that is also not possible because the layer is stable. Option C, turbulent air, again wrong. Poor visibility, okay. Fog, okay. Low stratus cloud, okay. Showery precipitation, again wrong because inversion layer is nothing but a stable air layer. So option Charlie is also eliminated. Next, what is meant by the term dew point? Dew point. Now let's say this is your certain parcel of air. Now you want to saturate this air layer, this air mass or parcel of air. To saturate it means, simple words, saturate it means to fill it with humidity, right? Now there are two ways you can do this. First, by evaporation of water, by evaporation of water, and all that evaporation of water, all that gaseous water vapor gets filled in this parcel of air, okay, or gets trapped in this particular parcel of air, and as a result this air mass becomes fully saturated, becomes packed with water vapor. Second, whatever water vapor is there in this air mass, okay, let that be, what you will do is you will cool this air mass, cool this air mass un- until saturation happens. Meaning, now there is this water vapor in the air parcel. There is so much space left where additional water vapor can be filled. You don't want to do that. You don't want to opt for option number one. With whatever available water vapor in this air mass, you want to make it saturated. So what you will do, you will have to cool this air mass up to its dew point temperature. Now what happens when you cool a certain object? When you cool, its volume decreases. So this air mass will start decreasing in size. It will start decreasing in size. So keep cooling, cooling, cooling. You will achieve one point in which the volume of this air mass will reduce in size to a very large extent, and at a particular point of time, the air mass, the size of the air mass, and the water vapor in it will be uh, the size of the air mass and the water vapor content will be enough make it to make it saturated. Okay, so these are two ways: either fill this air mass with new and new water vapor and pack it. If that is not possible, so what you do is you cool this air mass until saturation is achieved, until dew point temperature is reached. The volume of this air mass decreases, and with the available water vapor in it, there will come a point of time when this air mass will become saturated with whatever water vapor content is inside. So there are two ways. So dew point is that temperature. So the temperature at which condensation and evaporation are equal, the temperature at which dew will always form, the temperature to which air must be cooled to become saturated. Option C is the correct option. Okay, so option C is the right definition. Next, now here they have given you an example of TAC, Terminal Aerodrome Forecast, at a particular airport in the United States. And there are two questions based on this TAC. Question number one, what does SHRA, that is Sierra Hotel Romeo Alpha, stand for? So let's read this tab for Kilo Mike Echo Mike. Okay. So first things first, you have the time of the time when it was issued. Next, you have the winds, visibility, haze, cloud condition broken at 3000 feet, the probability 40%. Then again from a new time, the visibility decreases. 5 statute miles becomes 1 statute mile. You expect thunderstorm and rain. Overcast clouds at 800 feet with CB clouds in them. Then from again a new time, the winds have changed. Now 200 at 12 knots has become 330, 15 knots, gusting 20 knots. Visibility P 6 statute mile. P means Papa means more than 6 statute miles. Broken clouds 1500. Overcast 2500. Probability again 40%. Again new time is given. Visibility has improved and thunderstorm rain has decreased in intensity and now you have showers and rain. So SHRA stands for shower and rain. So rain showers, a shift in wind direction is expected, a significant change in precipitation is possible. So full form is rain showers. Next, question 6. Between 10 o'clock UTC time and 12 o'clock UTC time, the visibility is forecast to be what? So look here. From 2 o'clock, these are the winds, clouds, probability this time, again visibility, uh, again other weather conditions. So over here, so BECMG means becoming. So this weather will change or will become from 10 o'clock to 12 o'clock UTC. You are going to expect changes in wind. Winds are calm, visibility is 3 statute miles. BR, Bravo Romeo is mist, MIST, mist. Sky clear, temporary from 12 o'clock to 14 o'clock, half a statute mile visibility with fog. So they have asked us about weather conditions in this time frame between 10 UTC to 12 UTC. So you have calm winds, you have 3 statute mile visibility, you have mist and sky clear. So let's answer the question now. Between 10 and 12, the visibility is 3 statute miles. Okay, simple. What is the characteristic of stable air? Stable air. Stratiform clouds? Yes. Stratiform clouds are nothing but low level clouds. Unlimited visibility. That is wrong. We have just checked or we just saw the example of inversion, which is a consequence of stable atmospheric conditions. Because of stability, the pollutants in the atmosphere remain trapped in lower levels of it. As a result, there is no turbulent mixing between the lower levels of the atmosphere and higher levels. If there is no turbulent mixing, these pollutants will remain suspended in the atmosphere, which will decrease visibility, which may result in condensation. Fog will happen if there is high humidity in the atmosphere. So visibility will not be unlimited. On the contrary, it will be poor or very bad. Cumulus clouds. Cumulus clouds are clouds of vertical development. Now clouds will develop vertically high if there are convective currents. Ground surface is very very hot. There are winds. Okay, there are turbulence. So none of these conditions is a characteristic or is a feature of stable air or stable atmospheric conditions. So cumulus clouds will not develop in stable air. Option A is right. Clouds, fog, dew will always form when? Always. Water vapor condenses, relative humidity is 100%, water vapor is present. So the most appropriate answer will be option A. Whenever condensation of water vapor happens, you will get a low level cloud, fog, dew. Now relative humidity can be 100%, but without condensation nuclei, without pollutants, without that, this relative humidity of 100% will not transform into clouds of fog or dew. Just having a relative humidity of 100% is not sufficient. You also need other favorable factors like condensation nuclei, cold temperatures, like that. Water vapor is present. Again, that is wrong. Okay, so you need condensation to happen. Okay, only and only then we will consider clouds, fog, or dew forming in the atmosphere. This we come to the end of this quiz lecture. I hope you understood all the 8 questions, the explanations I gave. If you have any doubt in that, let me know in the comment box. I will address them and resolve and clarify to your understanding. I also hope that you have learned something new today. You come across some new concept, new question, new topic understanding. So that is the main purpose of this lecture. I request you all to subscribe to this channel and like this video lecture. Do share this video lecture with all your other friends. More you practice questions, more confident you become to appear for your exams. All the best. Keep watching next video lectures and